Alrighty, today we're going to do lesson 4 of this unit. It's all about exponents. Now this section's got a lot of stuff in it, but we'll go back in a couple days to go over some of the kind of missing pieces or go in a little more depth. When we talk exponents, remember this is what we kind of mean by it. Just some random example here, 2 to the 5th. It doesn't mean 2 times 5. It means you are taking 2 and multiplying it by itself with 5 different 2's here. 2, another 2, another 2, another 2, and another 2. 2 times 2 times 2 times 2 times 2 is 32. That's what exponents is. Now some of these will have some different rules here that we're going to go through. Our first example we're going to have here is 2.5 to the third power. We need to figure out what that is. 2.5 raised to the third power. What is that value? And we'll figure that out here in a minute. So now that we got the calculator popped up here, really all you can do, or all you really need to do in this one, is just take 2.5, take it times another 2.5, and then take it times another 2.5, and you'll get this answer, which is 15.625. Now, there are some options depending on what the calculator you have. You could have also, on this one, I'm just using the one that's built in, and took it to the third power. That button's there, because that's huge. Or you could have went 2.5 and then raised it to a certain power. That's that little caret button, so Shift 6. Or if you have a nice high-tech scientific calculator on your own, it depends on what yours is, and I can look at it if you are completely clueless on that when it gets to that point. So that's just the first thing of exponents, just knowing how to do it, making it to that power. Right? Next thing we're going to talk about is these negative exponents. Really means repeated division. Actual exponents are repeated multiplication. What we have here, our example, just our algebra look, a to the negative nth power is equal to 1 over a to the n power. So when you see anytime you see a negative exponent, you need to flip it. So if it's not a fraction, you'll make it a fraction. If it already is 1, you'll just flip it onto the top side, and you get rid of the negative exponent. We're going to show a couple different looks to this in our next few examples. So that's what negative exponents is all about. Example number 2, what expression is equal to 5 to the negative third? What is the expression? We're not looking for the actual answer, although we'll answer that question too. What expression is actually equal to 5 to the negative third power? So here we go, 5 to the negative third power. Since we see a negative power, I'm going to make this a fraction even here. It's really like written over 1. Anytime it's not a fraction, you can always put it over 1, make it a fraction. Take that negative power, you're going to put it on the bottom. Change the exponent to positive. That's why you've done it. You should never end up with negative exponents unless it explicitly tells you to leave it negative exponents. It rarely does that. Got to have something on the top. You put the 1 there. It's almost a placeholder. There you go. That's the expression we wanted to know. If you wanted to know the answer, so let me write this in really quick. That's the expression you need to know. And then, if you want to know the actual answer, you take 5 to the third. 5 to the third, 5 times 5 times 5 is 125. So 1 over 125 is the actual answer. But the expression part is what the question was explicitly asking. So this is the 1 over 5 to the third. You're just trying to get rid of the negative exponents when we have something like that. Now, so we flip back here, go to example number 3, another one with negative exponents, but we have a fraction. This is the value of 1/2 raised to the negative 4th power. Alright, here we go. Beautiful parentheses, I know. 1/2 to the negative 4th. Same thing as before. You've got to get rid of the negative exponents. You have to flip this fraction. So this will become 2 over 1. or it would be simply 2, and the exponent goes to positive. So if you get a fraction raised to a negative power, flip the fraction and change the exponent to positive. So this is just now 2 to the 4th. 2 times 2 times 2 times 2 is going to get you the answer 16. So that's the value of what 1/2 to the negative 4th is. So even if you weren't 100% sure of that, you could always just check that. 1 divided by 2 is 0.5 and raise it to that x to the y button. That's raising it to a certain power. Oops, I didn't do that right. Hang on. There you go. So you can always double check it with a calculator, but again, you never know what this question would be on an ECA. Is it calculator based or is it not? So my suggestion, don't do it on a calculator and then check it to make sure you've done it right. So that's what you got to do. Fractions raised to a negative power. Now the next thing we're going to talk about is multiplying exponents together. When they have the same base, in this case a can't be 0 or makes no sense. Any integers in the world, m and n, if you have this, a to the m times a to the n, you will add your exponents and end up with a to the m plus n power. If the bases are the same, add the exponents. Okay, so we're just going to deal with some integers. You will get some fractions later tomorrow or the next day, so we'll do that then. Here's example number 4. Ignore this thing. That's my fault. What is the simplified expression? 3 to the 8th times 3 to the 2nd. 3 to the 8th times 3 to the 2nd. What is that expression? Okay, here we go. That's what we have. We're going to write this out. 3 to the 8th times 3 to the 2nd. Bases are the same. The base is 3. We're going to add up our exponents. 8 plus 2. Not exactly a hard math problem there. You're going to get 3 to the 10th. That's the expression we want to know. It's not asking for what is 3 to the 10th. That's crazy to ask for. I mean, you can calculate it, but I'm not asking that. So here is your expression, 3 to the 10th. You just add up the exponents. So that's our multiplying exponents. And again, if you get stuck or something doesn't make sense, either email me or let me know the next day so we can get all of our questions clarified here. So that's example number 4. There are 7 of these suckers, so bear with it. Next topic, we're going to divide exponents. Same starting point, any base a can't be 0, any integers m and n. If we have a to the m power over a to the nth power, you will subtract your exponents. You will have a to the m minus n power. So multiplying exponents, you added them. Dividing exponents, you subtract. Bases are the same. Again, if it looks like a division problem, you're going to subtract the exponents. We'll see an example here in a second. Okay, here we go. Example number 5. What is the simplified form of this expression? We have 5 to the 12th all over 5 to the 4th. 5 to the 12th over 5 to the 4th. Give it a minute and we'll come back. Alright, here we go. Division means you subtract your exponents. Twelve minus 4, that's going to give you 8. So you have 5 to the 8th power. That is that expression again. We're not looking for the actual answer. That would be tremendous if we could do it, but we're not worried about that. Now, there is another thing you could do. I'm going to make something here. Let's suppose you can't remember the rule, or you're not 100% sure. I'm going to move this number. 3, 6, 7, 8, 9. Now this is what we could do. You could do this on anything. It would be a lot more work, but let's suppose you can't remember that rule and save your life. This is what we would have if we wrote it all out. 5 to the 12th is 5 times all that. 5 to the 4th, 5 times 5 times 5 times 5. And then you could just cancel things out. 5 on top, 5 on bottom, gone. 5 times 5 on top, 5 on bottom, gone. Same thing, same thing. See what you're left with. And then you have all these 5s multiplied with each other. So here you're going to get back to 5 to the 8th. So there is always that alternative here that you could do. Again, a lot more work, especially if you got crazy big exponents, but that option is out there just so you are aware or haven't forgotten all about it. So that is dividing exponents. We have 2 more things to talk about here. Alright, here we go. Powers of powers. Power 2 of power, if you look down here. Any base x that is not equal to 0. Integers m and n. If you have this, x to the mth power, all taken to the nth power, you will multiply your exponents and have x to the m times n power. So anytime you get power to a power like this, look, you will multiply. X to the mth power taken to the nth power, you will have x to the m times n power. So that is that rule. Nice little multiple choice question this time. Which expression has the same value as 3 to the 3rd taken to the 5th power? You got your 4 options: A, 3 to the 8th, B, 3 to the 35th, C, 3 to the 15th, or D, 3 to the 243rd. Remember your rule we had just literally 15 seconds ago. Answer the question. A, B, C, and D. Okay. 3 to the 3rd taken to the 5th. Remember, power to a power, you're going to take these 2 little exponents up here and multiply them. Has nothing to do with this 3. It stays the same. 3 times 5 up here. 3 times 5 is 15, so we are left with 3 to the 15th. Come back to our answers here. 3 to the 15th. Correct answer is C. So there we go. Power to power, multiply your powers. Okay, we have one more thing to talk about. Powers of products. For any bases A and B, both can't be equal to 0, and we have some integer n. If we have A times B all raised to the nth power, you will take each part inside that parenthesis, each part in that product, and take it to the nth power. So we will come up with A to the n, B to the nth power. You have a product in here, like a 2x or something like that, taken to the 3rd power. You would take 2 to the 3rd and the x to the 3rd. So make sure you take each part of that product, you hit the button, and then take it to that power. We have one last example here. Example number 7, which expression is equivalent to 2 to the 5th times 3 to the 4th? 2 to the 5th times 3 to the 5th, all raised to the 4th power. And I put a little note up here. I have to use the x. There is no good symbol for multiplying other than that. Sorry. Fine. Sad face. So are we going to come up with 6 to the 9th? That's choice A. Are we going to come up with choice B, 2 to the 9th times 3 to the 9th? We're going to come up with C, 6 to the 40th? Or are we going to come up with D, 2 to the 20th times 3 to the 20th? Give it a minute, try to process it, think about it. Not sure of yourself, give a good guess, and we'll see if you're right. So here's our problem. We have 2 different parts, so this is treated like a product. So our first step we're going to do is we're going to take 2 to the 5th taken to the 4th power, taken to this power out here. We'll also have 3 to the 5th taken to that power, the 4th power. Now we go back to another rule we had. Power to power. Multiply your powers. 5 times 4 is 20, so we're going to have 2 to the 20th. Same thing here, 5 times 4, there's another 20. We have 2 to the 20th times 3 to the 20th. Now, another thing to note, bases are different. So we have a base of 2 here. We have a base of 3 here. There's nothing we can do besides leave it like that. Bases are different. You can't add those up. You can't combine it and call it 6. That rule does not exist for exponents. So when you have something like this, bases are different. You have to leave it as it is. So you will come up with 2 to the 20th times 3 to the 20th. And then the only thing that makes that work is choice D. Alrighty. So that is exponents, pretty much all the rules, and we're going to come back, as you maybe be able to see on the side. That's what we're going to do the next couple days, is some exponents review, fill in some of the gaps, go over it a little bit more than this. So this is not a one-day thing, this is more like a 3-day thing. So if you got questions, email them, or wait till the next day and go, okay, I didn't have a clue what you were getting at. Make sure you ask, that's your job. Make sure you understand it. Your job is to make sure I'm doing my job, I guess. Alright, enough rambling. We're done. Have a good rest of the day, night, wherever you're watching this. See you back tomorrow.